Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to gravitation. So far we have discussed the basic concepts related to gravitation and gravity, universal law of gravitation, and the experimental determination of the universal gravitational constant, the Cavendish experiment. So in this video we are going to discuss another important concept, which is the principle of superposition of gravitational forces. So far we have discussed that as per Newton's universal law of gravitation, every object in the universe, it attracts every other object with the force which is called as the gravitational force, and that gravitational force, it is directly proportional to the product of the masses of those two objects and inversely proportional to the separation distance between them. Combining these two equations, we get the mathematical representation of the gravitational force, which is equal to F is equal to g m1 m2 by r square, where g is the universal gravitational constant and that value is equal to this much. Okay. Now for the principle of superposition, we have to represent this equation. This is in scalar form. This is the scalar representation. As force is a vector, this is the scalar representation. We have to represent it in vector form. Okay. So for that, for the vector representation, we will say the same thing. Let there be two masses, m1 and m2. Okay. Now these two masses, they are at a distance of r. Okay, they are at a distance r away from each other. Now here F12 vector, okay, F12 vector is the force, gravitational force exerted on mass m1 by mass m2. That's what F subscript 12 vector means. Gravitational force exerted on mass 1 by mass 2, and the direction is towards m2 because it is attracting it towards itself. It is towards the mass m2, F12, gravitational force acting on mass m1 by m2, and it is towards m2. Similarly, F21 is the gravitational force acting on 2 or exerted on 2 by mass m1. Okay, F21 is the gravitational force exerted on mass m2 by m1. Gravitational force of attraction exerted by m1, it is towards m1. Okay, every other object tries to attract the other object towards itself. That's why the gravitational force is towards the other attracting body. Okay, F12 towards m2, F21 towards m1. Okay. Now here R12 cap is the unit vector from mass m1 to 2. R12 is the unit vector connecting mass m1 to m2. Okay, and R21 cap is the unit vector connecting mass m2 to m1. Actually it is this here. Okay, here both R12 vector magnitude is equal to R21 vector magnitude, which is equal to R. Okay, here the magnitude of both the displacement vectors, that is the separation distance between m1 and m2, whether you say R12, that is from 1 to 2, the displacement from 1 to 2, or from 2 to 1, it is the magnitude wise, it is the same. But as displacement is a vector, when you say the displacement from mass m1 to m2, it is R12 vector. And when we say displacement from mass m2 to m1, or the displacement vector connecting m2 and m1, it is R21 vector. Magnitude wise they are the same. And R12 cap, which is the unit vector, that is equal to R12 vector by R12 vector modulus. Similarly, R21 cap, that is equal to R21 vector by R21 vector modulus. Okay, here. Okay, so the expression, the same expression, that is this, the gravitational force expression, when we write it in vector format, it is like this. The gravitational force exerted on mass m1 by m2, that vector is equal to minus g m1 m2 by r square r21 cap. So here, if you see, we are saying F12 vector is force exerted on mass m1 by m2. Okay, this F12 vector, force exerted on mass m1 by m2, and here the vector which we are using is the displacement vector connecting m2 to m1. Gravitational force is exerted by m2 on m1. Okay, gravitational force is exerted by m2 on m1, so that's why the source vector starts from here, m2 to m1. See, F12 vector, gravitational force exerted on 1 by 2. So the body which is exerting the gravitational force, that becomes the originating point of the displacement vector. That's why R21 vector. Similarly, F21 vector, gravitational force exerted on 2 by 1. So here the attracting gravitational force, which is the body which is exerting the gravitational force is 1. Okay, mass m1. So that's why the source vector here will be R12 vector. That's why here R12 cap, that is used. Same thing but R12 cap. And here magnitude wise, both these forces, they are the same in magnitude, but the direction is opposite. And here the minus sign is used because F12 vector is opposite to R21 vector, F21 vector is opposite to R12 vector. Okay, see, F12 is opposite to R21, that's why minus, F21 is opposite to R12, that's why minus sign. Okay, and here both these forces, they are equal in magnitude and opposite in direction. That's why they constitute an action and reaction pair, as R12 cap is equal to minus R2 cap. Okay, that's why F12 vector is equal to minus F21 vector. They are equal in magnitude but are acting in opposite directions, constituting an action and reaction pair. Okay, so always remember, the body which is exerting the gravitational force on the other, the displacement vector originates from that mass or that body. Okay, so that's why here in the first case, gravitational force exerted on mass 1 by 2. So mass 2 is the object which is exerting the gravitational force. That's why the displacement vector starts from 2, R2 to R, that is from 2 to 1. That's why this displacement vector. Similarly here, gravitational force exerted on 2 by mass m1. So mass m1 is the object which is exerting gravitational force on m2. So displacement vector starts from m1 to m2, R12. Okay, so this is the concept, and this is the representation, the vector representation of gravitational force of attraction between two masses. Okay, now the principle of superposition of gravitational forces. Now if you remember, when we studied the characteristics of gravitational force, we discussed one point where it was written that the gravitational force of attraction between two bodies is independent of the presence of other bodies. Okay, and there I explained that no matter how many objects are there present in the surrounding, the gravitational force of attraction between a two bodies, one pair which constitute a pair, that will always remain unaffected and it will remain independent. It will not be influenced by the presence of other bodies. And the resultant gravitational force on one single body due to a number of other surrounding bodies is the vector sum of gravitational force exerted by each and every surrounding body on that particular body. That's why we studied the vector representation of gravitational force. So here these are the two important points of principle of superposition of gravitational forces. The gravitational force between two bodies, it is independent and uninfluenced by the presence of other bodies. The resultant gravitational force acting on a particular body is the vector sum of gravitational force exerted by the surrounding bodies on that particular body. Okay, so let us say we have four objects, four masses, okay, m1, m2, m3 and m4. Now let us say m1 is the target object, target mass, and we want to find out the total gravitational force which is exerted on m1 by these three surrounding bodies, that is m2, m3 and m4. We want to calculate the net gravitational force, the total gravitational force acting on m1 because of these three surrounding bodies. Now here m1 and m2 constitute a pair, m1 and m3 constitute a pair, m1 and m4 constitute a pair. So there will be a gravitational force of attraction between m1 and m2, there will be a gravitational force of attraction between m1 and m3, there will be a gravitational force of attraction between m1 and m4. So F12 vector, that is the gravitational force exerted on one mass m1 by mass m2, it is towards the center of m2, okay, originating from the center of m1 directed towards the center of m2, F12 vector, because it is attracting mass m1 towards it. Similarly, F13 vector is the gravitational force exerted on mass m1 by m3. Same, it is originating from the center directed towards the center, okay, originating from center of m1 directed towards center of m3. Similarly, F14, it is the gravitational force exerted on mass m1 by m4, okay, same concept, F14 vector. Now the total force acting on mass m1, it is the vector sum of these three forces, F12 vector plus F13 vector plus F14 vector. Now suppose there were n number of bodies present here, so the total force would have been the nth force acting exerted on mass m1 by that nth body. So that's why I've used this expression. No matter how many number of bodies are present there, it will be the vector sum of all those gravitational forces. So here only three bodies are present, m2, m3 and m4. That's why F1 net, the total gravitational force exerted on mass m1, it is equal to F12 vector plus F13 vector plus F14 vector. Now here I always said that the gravitational force always acts in a opposite direction from the displacement vector. So here, for example, F12 vector, gravitational force exerted on mass m1 by m2. So here the displacement vector will start from m2 to m1, here R21 vector, opposite to F12 vector, okay, it will start from m2 to m1. Similarly, F13, okay, from m1 to m3, the gravitational force exerted on m1 by m3. So the displacement vector, it will start from m3 to m1 in this way, R31 vector. Similarly, F14 r41, opposite direction, and the vector representation of the gravitational forces, it will be like this. F12 vector is equal to minus g m1 m2 r21 square r21 cap. That is the unit vector. F13 vector is minus g m1 m3 by r31 square r31 cap. F14 vector is equal to minus g m1 m4 r41 square r41 cap. Okay, it is similar to the vector representation of the gravitational force which we just studied here. Okay, the gravitational force vector is always in the opposite direction to the displacement vector between the two masses. That's why the minus sign is present here. Now the total force acting on it, that is acting on mass m1, it is the vector sum of these three gravitational forces, and it is uninfluenced, unaffected by the presence of these neighboring bodies, by which I mean that the gravitational force between m1 and m2 is not affected by m4 and m3. The gravitational force between m1 and m4 is not affected by m2 and m3. The gravitational force between m1 and m3 is not affected by the presence of m2 and m4. They all, the gravitational force between the neighboring bodies, they constitute a pair and they behave separately, independently, without being affected by the presence of other bodies. Okay, all of them are separate and then they are added together to get the total force acting on a particular mass. Okay, so this is the concept of principle of superposition of gravitational forces. Okay, first we discuss the vector representation of the universal law of gravitation. Okay, and then we discuss the principle of superposition of gravitational forces. Okay,